Fine, let's start. Number 1. The Atacama Alien Mummy. In the year 2003, someone digging behind an abandoned church in the ghost town of La Noria, deep in Chile's Atacama Desert, pulled a tiny body out of a leather pouch. It was barely 15 centimeters long, about the size of a large hand. It had a skull stretched into a cone, eye sockets that slanted at a strange angle, and only 10 pairs of ribs instead of the usual 12. To anyone who wanted to believe, it looked like proof. It looked like an alien. In 2013, the little skeleton became the centerpiece of a documentary called Sirius, presented as possible evidence of extraterrestrial life. Millions of people saw it. The nickname stuck. Eta, the alien of the Atacama. But a small body in a desert is exactly the kind of puzzle modern science was built to solve. A Stanford immunologist named Gary Nolan took on the case, and in 2018 his team published a full genomic analysis. The verdict was blunt. Eta was human, not human-like, not close to human. A human girl with ancestry rooted in South America. The genome had survived because the Atacama is one of the driest places on Earth, and dryness preserves DNA beautifully. Now here's where it gets interesting. A bone specialist read the skeleton as roughly 6 years of development, even though the body was the size of a fetus. That contradiction pointed straight at the genes. The team found mutations in a cluster of genes with names like KOL1A1, FLNB, and PCNT, genes tied to bone growth, to dwarfism, to scoliosis, to skeletal dysplasia. The cone skull was not alien design. It was premature fusion of the skull plates, a known human condition. Otto was a preterm child with severe congenital anomalies, and she probably died within the last century, not thousands of years ago. Some scientists pushed back, and not on the biology. They argued that a miscarried human infant deserves a burial, not a genome study, and Chile opened an inquiry into whether the remains had been taken illegally. The alien story collapsed the moment whole genome sequencing was applied. It is worth pausing on why the myth spread so easily. The real engine was pareidolia, the human habit of reading meaning into shapes, combined with a strong desire to believe. La Noria was a nitrate mining town, abandoned more than a century ago, an eerie setting that only added to the drama. And the strangest scientific detail is that Ada carried an unusually high number of harmful mutations all at once, which is exactly what made the tiny skeleton look so wrong. Gary Nolan himself noted that the case had genuine research value, precisely because of that rare cluster of anomalies. So if a skull that looked completely alien turned out to be tragically human, what happens when a skull that looks human turns out to be something we had only ever known from DNA? For that answer, you have to look inside a well. Number 2. Dragon Man. In 1933, a laborer working on a bridge over the Songhua River near Harbin in northeastern China found an enormous human skull. This was during the Japanese occupation, and rather than hand it over, he hid it. He wrapped it up and dropped it to the bottom of a well, where it sat, forgotten, for about 85 years. Only around 2018 did his family recover it and donate it to a university. What emerged from that, well, turned out to be one of the most complete archaic human skulls ever found. It has a massive brain case, with a capacity of roughly 1,420 milliliters, squarely within the range of modern people. But the face is strange. It carries heavy, primitive brow ridges over flatter, almost modern cheekbones. In June of 2021, a team led by Qiangji and Shijun Ni gave it a new species name, Homo longi, meaning Dragon River Man, after the Black Dragon River region. Uranium series dating placed it at least 146,000 years old. And then the real argument began. Because there was another possibility. The Denisovans. This is a human group first identified in 2010 from a single finger bone in a Siberian cave, known almost entirely from DNA. We had their genome, but not their face. Could Dragon Man be the face of the Denisovans? The paleoanthropologist Chris Stringer argued the Harbin skull sat right next to that lineage. Then came the breakthrough. Researchers extracted ancient proteins and mitochondrial DNA from the skull itself and from the hardened plaque on its teeth. The molecules linked Harbin to the Denisovans. The skull hidden in a well may finally give a face to a ghost. This is the power of a young science called paleoproteomics, sequencing ancient proteins that survive long after DNA has decayed, past 100,000 years. And Denisovans are not just an academic curiosity. Their DNA lives on today in people across Melanesia, Australia, and Tibet, where one Denisovan gene, called EPAS1, helps people survive the thin air of high altitude. That is the deeper significance of Dragon Man. For more than a decade, the Denisovans were a genome without a face, known from a fingerbone and a jaw. A robust, large-brained population had lived across Middle Pleistocene Asia, and now, at last, we may be looking at what one of them actually looked like. From a face pulled out of a well, the trail of solved mysteries runs to a set of giant spirals pulled straight out of the American prairie. Number 3. The Devil's Corkscrews. In the Badlands of western Nebraska, in the late 1800s, ranchers kept finding something impossible. Towering spirals of stone, 2 to 3 meters tall, corkscrewing straight down into the ground before ending in a slanted chamber. They called them Devil's Corkscrews. The scientific name became Demonelix, the demon screw. A geologist at the University of Nebraska named Erwin Barber began describing them in 1891, and he was baffled. First he guessed they were giant freshwater sponges. Then he decided they were the fossilized roots of huge extinct plants. Other scientists, including Theodore Fuchs, said, no, these are animal burrows. And that argument dragged on for decades. The spirals date to the early Miocene, roughly 20 to 22 million years ago. The mystery broke when someone finally found what was inside them. Skeletons. Small, curled skeletons of an extinct beaver called Paleo castor, an animal about the size of a muskrat. This was a beaver that did not build dams. It dug, and the walls of the corkscrews held the proof. The grooves were tooth marks, not claw marks, which meant these beavers excavated their spiral homes by chiseling the soil with their front teeth. The helix shape was clever engineering. It gave a stable temperature, good drainage, and protection from predators. And Paleo castor lived in colonies, so the Badlands were once dotted with these burrows, like a prairie dog town made of screws. In the 1970s, Larry Martin and Deborah Bennett confirmed the picture. The sediment that filled the empty tunnels hardened into stone, so each corkscrew is a perfect natural cast of a burrow that a beaver dug and then left behind. Today, the Devil's Corkscrews are recognized as one of the finest trace fossils on Earth, a fossil not of a body, but of behavior, protected at Agate Fossil Beds National Monument. It took connecting the empty spiral to the animal inside it to solve a puzzle that had defeated the first scientists entirely. And connecting a body to its context is exactly what it took to correct one of the most famous misidentifications in the history of archaeology: a body soaked in red. Number 4. The Red Lady of Paviland. In 1823, in a cave called Goat's Hole on the Gower Peninsula in South Wales, a pioneering Oxford geologist named William Buckland uncovered a human skeleton stained a deep, vivid red. The color came from powdered ochre that someone had scattered over the body during burial. Buckland was working inside a strict biblical time frame, one that did not allow for a truly ancient human. So he looked at the bones and the ornaments buried with them, and he reached a confident conclusion that was completely wrong. He decided this was a Roman-era woman, perhaps a prostitute or a witch. He called the skeleton the Red Lady. There were two problems. The skeleton is male, and it is not Roman. Modern radiocarbon dating has pushed the burial back again and again, and now places it at roughly 33,000 to 34,000 years old. That makes the Red Lady the oldest known ceremonial burial of a modern human in Britain, and one of the oldest in all of Western Europe. The young man, who died around 25 to 30 years of age, was buried with real care. Beside him lay ivory rods, fragments of an ivory bracelet, and seashells pierced to be worn. He belonged to the Upper Paleolithic world, the Origin and early Gravettian cultures. Isotopes locked in his bones show a diet rich in animal and marine protein. And here's the strange part. When he was buried, the sea was far away. Ice had locked up so much water that sea levels were low, and the cave looked out not over a beach, but over a vast open plain, with Britain still joined to continental Europe. The mammoth ivory in his grave had to be worked and carried some distance. Researchers including Thomas Mollison re-examined the bones, and radiocarbon specialists like Tom Hyam refined the dates in the 2000s. The red ochre likely stood for blood, for life, for ritual, a practice that appears in Paleolithic burials across Eurasia. 2 centuries of a mistaken label were undone by a single dating method. And dating, combined with chemistry, is exactly what rescued the next mystery, an object of gold and bronze that was very nearly lost forever. Number 5. The Nebra Sky Disc. It is a disc of bronze about 30 centimeters across, inlaid with gold, and it may be the oldest concrete map of the sky that human beings ever made. On its blue-green surface, gold shapes show a sun or full moon, a crescent, and 32 stars, including a little cluster that looks like the Pleiades. 2 gold arcs on the rim mark the angle between where the sun rises and sets at the solstices, at that exact latitude. The trouble is how it came to light. In 1999, looters with metal detectors dug it up near Nebra in Germany and sold it on the black market. It might have vanished into a private collection. Instead, in 2002, police ran a sting operation in Basel and recovered it, and the finders were prosecuted. Because it had been ripped from its context, its age became the central question. The disc was found with Bronze Age swords, axes, and chisels, and those placed it at around 1600 BCE, in the early Bronze Age. In 2020, one paper argued it was actually far younger, from the Iron Age. The original researchers pushed back hard, and the earlier date has held. And this is where the science gets beautiful. Chemical analysis traced the metals. The copper came from the Mitterberg region in Austria. The gold, originally, came from Cornwall in England, and so did the tin and the bronze. A single object in central Germany was built from materials that had traveled across a continent, revealing Bronze Age trade networks of astonishing reach. The astronomer Wolfhard Schlosser analyzed the solstice arcs and the star cluster, and the archaeologist Harold Meller led the effort to study and display it. The disk appears to have been modified in stages, with the arcs and a golden sunboat added later, and the Pleiades may have signaled when to plant and harvest. What finally silenced the forgery doubts was the corrosion itself. The layers of patina that build up over thousands of years are extremely hard to fake, and metallurgical analysis confirmed them. In 2013, UNESCO added the disk to its Memory of the World Register. From reading the sky, the trail of solved mysteries turns to reading the DNA of an entire vanished people. Number 6. The Etruscan Origin Mystery. Before Rome ruled Italy, the Etruscans did. From around 900 BCE, they built a sophisticated civilization in the region we now call Tuscany, with remarkable art, engineering, and metalwork. And they spoke a language that was not Indo-European, written in an alphabet borrowed from the Greeks, a language we still only partly understand. That strange, isolated tongue fueled a mystery that lasted more than 2,000 years. Where did the Etruscans come from? The ancient Greek historian Herodotus had an answer. He said they were migrants, refugees from Lydia in Anatolia, in what is now Turkey, driven west by a famine. But another ancient writer, Dionysius of Halicarnassus, disagreed completely. He said the Etruscans were native to Italy, that they had always been there. For 20 centuries, no one could prove which man was right. Were the Etruscans Eastern migrants or local Italians? Early DNA studies, based only on the mitochondrial line, gave hints that leaned toward Anatolia, and the debate stayed alive. Then, in 2021, a landmark study in the journal Science Advances settled it. A team including Cosimo Post, David Caramelli, and Johannes Krauss analyzed genome-wide ancient DNA from 82 individuals, spanning from about 800 BCE to 1000 CE. The result was clear. The Etruscans were genetically local. They shared the same ancestry as their Latin-speaking neighbors, including the steppe-related ancestry found across Italy. There was no significant recent influx from Anatolia. Herodotus, on this point, was wrong. Dionysius was right. And that produced something genuinely surprising. The Etruscan language, that mysterious non-Indo-European isolate, had been preserved by a population that was, in its genes, thoroughly Italian. Language and ancestry had come apart. A people could keep an ancient tongue while sharing the bloodline of everyone around them. The study did find a later change. During the Roman imperial period, Eastern Mediterranean ancestry did arrive in the region, but that was the cosmopolitan mixing of the empire, long after the Etruscans first appeared. Genomes had answered a question that texts alone had argued over since antiquity, and when it comes to dating a catastrophe rather than a people, science had to end a war between two clocks over an island that blew itself apart. Number 7. The Minoan Eruption of Thera. The island we now call Santorini was once home to a thriving Bronze Age town called Akrotiri, part of the brilliant Minoan world. Then the volcano beneath it erupted in one of the largest volcanic events in all of human history, rated around VEY 7. It buried Akrotiri under meters of ash and pumice, freezing multi-story buildings and vivid frescoes in place, a Bronze Age Pompeii. But unlike Pompeii, there are almost no bodies. The people seem to have felt the warnings and fled before the final blast. The eruption sent tsunamis and ashfall across the Aegean and helped destabilize Minoan Crete. For decades, scholars fought a bitter war, not over what happened, but over when. It was called the high chronology versus the low chronology. Archaeologists, tracing links between Aegean and Egyptian pottery, argued for a date around 1500 BCE. But radiocarbon dating kept pointing about a century earlier, into the late 1600s BCE. The gap seemed impossible to close, and it mattered enormously, because the date of Thera anchors the entire timeline of the Eastern Mediterranean Bronze Age. Then, science found a living witness. A Danish team led by Walter Friedrich discovered an olive branch that had been buried alive by the eruption, still in growth position. In 2006, they radiocarbon dated it to roughly 1627 to 1600 BCE. To narrow it further, researchers turned to tree rings. Frost damage and growth anomalies in bristlecone pines and Irish oaks pointed to a major event around 1628 BCE. In 2020, a study combined tree rings with radiocarbon in a technique called wiggle matching, testing the chronologies year by year. And Charlotte Pearson and colleagues used annually resolved tree ring radiocarbon to do the same. Greenland ice cores preserve spikes of volcanic sulfate, though matching a specific layer to Thera has stayed contentious. Slowly, the weight of evidence has pushed most estimates toward the late 17th or early 16th century BCE, closing the gap between the two clocks. Dendrochronology and radiocarbon together disciplined a date that pottery alone could never fix, and the stakes were never merely academic. Because the Thera date connects to Egyptian records, shifting it by a century reshuffles the sequence of kings, trade, and collapse across the whole Bronze Age world. Some have even speculated that the memory of this vanished island civilization echoes in the later legend of Atlantis, though that remains a fringe idea rather than a scientific claim. And if science can expose the true date of a real catastrophe, it can also expose something more embarrassing, a catastrophe that was completely fake. Number 8. The Piltdown Man Hoax. In 1912, an amateur antiquarian named Charles Dawson announced a spectacular find from a gravel pit at Piltdown in Sussex, England. It was a skull that combined a large human-like brain case with an ape-like jaw. Here, it seemed, was the missing link, the creature caught halfway between apes and humans. It was named Eoanthropus dawsoni, Dawson's Dawn Man, and Arthur Smith Woodward of the Natural History Museum reconstructed it and defended it. The fossil was embraced because it fit what people wanted to believe, that the human brain grew large first and the jaw modernized later. For about 40 years, Piltdown Man distorted the entire study of human evolution. It made genuine fossils, the real ancestors being dug up in Africa and Asia, look like anomalies that did not fit. But those African fossils and Peking Man kept telling the opposite story. The jaw modernized first, and the brain grew later. The contradiction became unbearable. In 1953, a trio of scientists, Kenneth Oakley, Wilfred LeGros Clark, and Joseph Weiner, took the specimens apart. A method called fluorine absorption dating showed the bones were far too young, and that they did not even belong together. The jaw was that of an orangutan. Its teeth had been filed down to mimic the flatware of human chewing. The bones had been stained with iron and chromic acid to fake the color of great age. Planted tools and animal fossils had been scattered to make the site look real. In 2016, a team led by Isabelle de Groot applied DNA analysis and CT scanning to the specimens. The molecular evidence pointed to a single orangutan, probably from Borneo, as the source of the jaw and teeth. The consistency of the materials and the methods pointed to one principal forger, Charles Dawson himself, a man with a documented history of other fakes. The imaging even revealed the putty and dental filling used to assemble the pieces. Piltdown succeeded partly on national pride, a Britain that wanted an ancient human of its own. Chemistry, and then DNA, turned a 40-year embarrassment into a solved crime. And from a fake disease of science, the trail runs to a real disease whose true origin was argued over for 500 years. Number 9. The Origin of Syphilis. Syphilis is caused by a corkscrew-shaped bacterium called Treponema pallidum. In 1495, a terrifying epidemic of it exploded across Europe, first recorded among soldiers at Naples, and it spread with frightening speed. Almost immediately, people began arguing about where it had come from, and that argument lasted half a millennium. One side held the Columbian hypothesis. Columbus and his crew had returned from the Americas in 1493, and the timing was damning. They must have carried the disease back with them. The other side held the pre-Columbian hypothesis. Syphilis, they argued, had always been in the Old World, simply misdiagnosed as leprosy. The bones could not settle it, because the whole family of treponema diseases, syphilis, and yaws and Bajel, leave very similar marks. A distinctive pitting of the skull called caries sicca and bowed saber shins. Specialists like Bruce Rothschild tried to separate the diseases by the shape of the lesions alone, but the ambiguity would not lift. What finally moved the debate was the ability to read the pathogen's own genome from ancient bone. In 2020, a team including Verena Schoenemann and Kertu Meyander recovered treponemal genomes from skeletons in early modern Europe, and found a surprising diversity of the bacteria around the very time Columbus returned. Then, in 2024, a study in the journal Nature, led by Kirsten Boss, sequenced treponemal DNA from skeletons in the Americas that predated contact. Those ancient American genomes formed the deepest branch of the family tree, supporting American roots for the whole treponemal group. The modern synthesis is more nuanced than either old camp. The disease family has deep roots in the Americas, yet related trypanomatoses may also have circulated in the Old World before 1492. The violent epidemic of 1495 may reflect a new, virulent American strain meeting a population with no immunity. Molecular clocks place the common ancestor of the strains within the last few centuries to roughly 2,000 years. By reading the genome directly, ancient DNA sidestepped the maddening ambiguity of look-alike bones. A 500-year-old whodunit became a question of strains and timing. And from one pandemic's origin, the trail leads to the deadliest pandemic in history, traced to a single lake. Number 10. The Black Death's origin. Between 1346 and 1353, the Black Death killed somewhere between 30 and 60% of the people of Europe. It is caused by the bacterium Yersinia pestis, carried by fleas on rodents. For centuries, one question hung over it. Where did this specific catastrophe begin? China, Central Asia, and the open steppe were all proposed, but no one could prove it. The clue turned out to be sitting in the ground for a very long time. Near Lake Issyk-Kul, in the Chui Valley of Kyrgyzstan, lie two old cemeteries. Their gravestones record a sharp spike in deaths in the years 1338 and 1339, and some of the inscriptions actually name the cause, using a word for pestilence. Those cemeteries had been excavated back in the 1880s, but the cause of that death spike stayed a mystery for well over a century. In 2022, a team led by Maria Spiru, Philip Slavin, and Johannes Kraus published the answer in Nature. They extracted Yersinia pestis DNA from the teeth of people buried there in 1338 and 1339, and the genome they recovered sat right at the base of what scientists call the Plague Big Bang, a moment when the bacterium exploded into many new lineages. That placed the Tian Shan region of Kyrgyzstan as the likely source of the Black Death, just a few years before it reached Europe. The strain was ancestral to the one that swept across Europe and the Middle East, and the local marmots are a known reservoir of plague, giving a natural, animal origin. What makes the case so elegant is that a historian, Philip Slavin, fused the written gravestones with the genetics, a true meeting of the archive and the laboratory. This does not mean plague never existed before. Yersinia pestis has ancestry reaching back to the Bronze Age, and earlier work by Verena Schunemann and Kirsten Boss in 2011 had already confirmed it as the Black Death pathogen. But the 2022 study pinned down exactly where and when this particular lineage emerged. From there, Silk Road trade carried it west, toward the Black Sea, where the Genoese siege of Kaffa in 1346 became a documented gateway into Europe. 10 mysteries, and every one of them cracked open by reading something almost invisible. Step back from the 10 stories and look at the tools, because the same handful of methods keeps appearing. Ancient DNA reads degraded genomes out of old bone and teeth, and it settled the Atacama mummy, the Etruscans, syphilis, and the Black Death. Where DNA has decayed too far, paleoproteomics reads ancient proteins instead, and that is what gave Dragon Man his identity. Radiocarbon dating, refined by ever-improving calibration curves, fixed the true age of the Red Lady of Paviland and helped date the Thera eruption. Dendrochronology, the science of tree rings, cross-checks radiocarbon year by year, and it was central to narrowing the Thera date. Fluorine absorption dating exposed Piltdown by showing that bones buried together were not the same age. CT scanning revealed the putty and filing hidden inside that forgery. Isotope analysis reconstructs ancient diets and movement. Metallurgical analysis of corrosion authenticated the Nebra Disc, because a genuine patina is extremely difficult to fake. Ichnology, the study of trace fossils, linked the devil's corkscrews to the beaver that dug them. And pathogen genomics does more than identify a disease. It maps where a strain came from and when it split apart. Each of these tools answers a question that older methods simply could not reach. The pattern is remarkably consistent. A wall stands for decades, and then one new technique arrives and the wall comes down. Just as important, these breakthroughs almost never come from a lone genius. They come from teams, historians working beside geneticists, chemists beside archaeologists. And none of it would be possible without the strange gift of preservation, the deserts and permafrost and volcanic ash and ochre that held these secrets long enough for the method to catch up. There is one more quiet hero in this toolkit, the molecular clock. By measuring how fast genetic changes accumulate, scientists can estimate when two lineages split, whether that is two strains of a bacterium or two branches of humanity. It was molecular clocks that helped place the common ancestor of syphilis strains within the last couple of thousand years, and molecular data that positioned the Black Death strain at the base of its explosive radiation. Put all of these methods side by side, and a striking fact emerges. Not one of them existed in a usable form a century ago. The tools that solved these mysteries were themselves invented within living memory. There is a humbling thread running through all of this. In almost every case, the evidence was already in human hands, sometimes for a very long time, before anyone could understand it. Piltdown Man sat unquestioned for 40 years. The gravestones at Lake Issyk-Kul had been excavated in the 1880s, roughly 140 years before their secret was read. The Red Lady of Paviland wore the wrong label for 2 full centuries. Dragon Man's skull spent about 85 years at the bottom of a well. The Nebra Disc was nearly lost to looters entirely. The Devil's Corkscrews puzzled trained geologists for decades, while the answer, quite literally, lay curled inside them. The lesson is that discovery and understanding are not the same act. Finding an object is only the beginning. The real work often waits for a tool that has not been invented yet. That has a striking implication for the present. Right now, in the drawers and storerooms of museums around the world, sit countless finds whose stories have not been read, because the method that will read them does not exist yet, or has only just arrived. Reanalysis of old collections has become a frontier as rich as any dig site. And because calibration curves and sequencing techniques keep improving, even finds that were dated decades ago are worth revisiting. The bottleneck, again and again, was never the material. It was the method. Consider how often the object was hiding in plain sight. A skull at the bottom of a well. A branch buried alive in ash and simply waiting. Gravestones with the cause of death carved right into them. Unread for a century because no one could confirm what killed those people. In each case, the answer was physically present the whole time. What arrived late was the ability to ask the right question in a language the evidence could answer. It would be dishonest to pretend every question is now closed. Several of these mysteries are solved only in part. Is Dragon Man truly a separate species, Homo longi, or simply the first good face of a Denisovan? Experts still disagree, and the naming may change. The exact year of the Thera eruption is narrowed to a tight band, but not nailed to a single season, everyone accepts. The precise strains and timing of treponema disease in the Old World before 1492 remain genuinely unresolved. The Etruscan language is still only partly translated, even though we now know who the Etruscans were. The full ritual meaning of the Nebra Disc is inferred from its symbols, not proven. Denisovan anatomy beyond a few skulls and bones is still sparse, which is exactly why Dragon Man matters so much. Matching a specific ice core sulfate spike to the Thera blast stays contentious. Even Atta's precise date of death is an estimate. And the deeper history of plague, its movements in the centuries before 1338, is still fuzzy. This is not a weakness of science. It is how science actually works. It narrows uncertainty rather than pretending to erase it, and it is honest about the edges of what it knows. these are not just satisfying puzzle solutions filed away in journals. Reading ancient pathogen genomes, as researchers did for syphilis and the Black Death, sharpens how we understand modern outbreaks, how diseases emerge, mutate, and travel. Denisovan genes, brought to light by discoveries like Dragon Man, still shape the bodies of living people, from immune systems to high-altitude endurance. The radiocarbon and tree ring calibration honed on the Thera debate underpins climate reconstruction as much as archaeology. The careful debunking of the Atacama mummy is a working model for how to answer misinformation, not with dismissal, but with data. Tracing the tin and gold of the Nebra Disc reveals how far ancient economies reached, reshaping our picture of prehistoric trade. The forensic techniques that cracked Piltdown, from chemical dating to CT imaging, cross straight over into modern crime laboratories. And the ethical debates around Atta about consent, repatriation, and respect for the dead are actively reshaping the rules of research. As museums digitize their collections, scholars anywhere in the world can re-examine a specimen without touching it. There is also a practical lesson in how the Black Death case was solved. It took a historian and a geneticist working as equals, one reading gravestones, the other reading teeth. That model of specialists who used to work in separate buildings now sharing a single problem is quietly transforming how we recover the past. What was once called a niche corner of archaeology has become its own recognized discipline, molecular history, where the laboratory and the archive finally speak the same language. Look back across all 10, and a single pattern stands out. Every one of these mysteries was waiting not for a discovery, but for a method. The objects were already found. What was missing was the way to make them speak. That is the real story hidden inside this video. An alien became a grieving family's lost child. A shameful fraud became a solved crime with a named culprit. A red lady became a young man buried with tenderness 34,000 years ago. A demon screw became the cozy spiral home of a prairie beaver. Genes and tree rings and corroded metal settled arguments that written words had left open for millennia. And notice what powers it all. Science's greatest strength here is not certainty. It is the willingness to overturn itself. Piltdown is the proof. A field that spent 40 years fooled, and then tore its own mistake apart in public. The most exciting thought is what it means for tomorrow. The next round of answers is almost certainly sitting in a museum drawer right now, mislabeled or misunderstood, waiting. Because the past does not keep its secrets forever. It keeps them only until the method arrives.